Howdy and welcome back. So we ran through a motivating example. We introduced some important terminology, and now we're going to move into functional style programming and give you a brief introduction to what it is. So what we've been doing today is moving towards C++'s support for functional style programming. As a style, functional programming emphasizes solving problems by composing functions rather than writing iterative statements, which is going to lead us to declarative rather than imperative code. And what we saw through this process is that we can create highly reusable higher order functions. Now, writing declarative code is going to allow us to tell the computer what we would want it to do, and then let it figure out how to accomplish whatever that is. For instance, consider the following code, where we're using the standard template library's copyIf algorithm to essentially iterate through a series and pull out all of the elements within that series that meet some sort of criteria. More specifically, looking at the code, we're going to store that result in this filter movies vector. So filtered movies is a standard template library vector storing movie objects. The arguments being provided to this copyIf function. We can see two iterators being provided, which is going to determine the sequence of elements on which this standard library algorithm is going to operate. Remember that begin is going to return an iterator to the first element within that sequence. So to the first movie. We said that end is going to return an iterator to one past the last element. We then, in a previous lesson, kind of went through, when we were introducing iterators, how we could use them to visit each element within the sequence. So movie 1, movie 2, and movie 3. And we'd stop looking once the whatever iterator we're using to iterate arrives at the end. Now, the additional or next argument here, this standard library back inserter, is essentially where elements that meet some sort of criteria are going to go. They're going to be pushed back to our filtered movies vector. And then the final argument to copyIf is going to be the criteria, the if portion of this algorithm's name. We're going to perform this pushback to filtered movies only if the movie that's being evaluated in the sequence has a release year of less than 1990. So the iterators are going to control the traversal. Each time we visit some movie M, we're going to check if its release date is less than 1990. If so, that movie is going to be pushed back to filter movies. If not, nothing will happen. Either way, we'll then move to the next element within our sequence, perform the same sort of evaluation until we've looked at every single valid element within our movies collection. Notice that there are many C++ standard library algorithms that are kind of higher order functions. We haven't talked a lot about today, but we can see kind of the awesome reuse that can arise from them. Notice here that this kind of copyIf function knows nothing about our movies, but it does know how to get from one movie to the next. And it can pass that movie that it's currently visiting to what we're going to call here, or introduce in a later lesson, this lambda function as m. Then, as specified, we determine the predicate for which whether or not this copy behavior will ensue. Key things to remember here is some of the power behind this. Let me just re-highlight this. Sorry, getting a little eraser happy. Is that the standard template library algorithms know nothing about the containers, and the containers know nothing about the algorithms. So how do they interact with one another? We said that interaction can happen through these iterators. So they kind of serve as the interface there. So using iterators, we have the means of traversing the elements of our collection. Remember, we implemented iterators for our singly linked list. We also implemented iterators that performed an in-order traversal of our binary search tree. And we could have passed both our beginning iterator and our ending iterator of either of our implementations to this copy standard template library algorithm and perform this sort of similar operation. We could have pushed back node data to a vector. We could have come up with more elaborate process to situate them somewhere else. But at the end, the major takeaway here is kind of looking at this, the multiple components going into this algorithm is that it's relying on iterators, but it's also a higher order function where its functionality or what it can do is highly reliant upon the function that is passed to it. And from there, I mean, we get power because we can be able to craft very elaborate sort of function predicates to dictate what it is the outcome of this operation will be. What is the if in that case that's going to determine what is copied over into this new vector here. So one thing to point out is that while C++ supports functional style programming, if you really want to learn functional programming, so not just functional style programming, but actual functional, kind of true functional programming, you should probably learn a more strict functional language like Haskell or OCaml. I believe you will do so in the programming languages class or equivalent here in our curriculum. So my assumption is that, yeah, you're definitely going to get some hands-on experience with a functional language at some point within our curriculum. Until then, let's go ahead and kind of look at functional style programming. And then the question becomes, okay, well, where are we going with all of this? What's next? In the next lesson, we're going to introduce function pointers and function objects, and we'll also discuss some of their advantages and disadvantage for each one respectively. We'll then introduce Lambda functions in a later lesson, and we'll talk about how it kind of takes the best from function pointers and function objects while not concerning itself with their disadvantages. Finally, we'll go ahead and revisit kind of a higher order implementation of a filter function. Maybe we'll do filter movies again, but we're going to pull this all together and then finish up this functional style programming and C++ theme of lessons here with that. So with that ado, I'll see you all tomorrow, and I hope you have a great rest of your day.